Welcome. All right, let's jump right into this explainer. Today, we're unpacking a really fascinating and honestly kind of profound preprint paper from the Machine Human Intelligence Lab, dated March 2026. It's titled The Cognitive Divergence, and it explores this widening structural gap that is actively forming right now between human and machine processing. We're going to pinpoint the exact moment AI surpassed our natural attention spans and dive into the behavioral loop that keeps us voluntarily giving away our cognitive power. Picture this scenario the researchers present. It's highly relatable for pretty much any knowledge worker today. Imagine a professional opens up their AI assistant and types, "Write a two-sentence reply declining this meeting." Boom. The model obliges instantly. The professional copies it, pastes it, hits send, and moves on, probably feeling pretty productive, right? I mean, we've all been there.
But here's the underlying question this forces us to ask, and it's a fascinating one. Why are we delegating a task that literally takes, maybe 30 seconds of unassisted brain power? Why outsource something so incredibly simple? Well, the paper argues this behavioral shift isn't just a matter of convenience. It's actually the symptom of a massive, slow-motion collision between our biological limitations and modern engineering. Section 1, the million-token race, artificial trajectories.
Okay, so to understand how this collision happened, we gotta look at the explosive growth of AI. Think of a context window as the AI's short-term memory, the sheer amount of text it can juggle in its mind at one single time. Back in 2017, the original transformer architecture struggled with a limit of just 512 tokens because of these steep computational bottlenecks. By 2020, we hit 2,048 tokens. But then, thanks to some major engineering breakthroughs, things like flash attention and rope, which fundamentally changed how data gets compressed, the architecture just broke past its natural barriers. The growth went completely nuclear. By 2023, models hit 100,000 tokens, a million by 2024. And by 2026, we are looking at models processing 2 million tokens simultaneously. It's wild. So, the crucial takeaway here is the staggering raw growth factor. AI context capabilities grew by a factor of 3,906 in just 9 years. With a doubling time of roughly 14 months, this trajectory is completely blowing past Moore's law. These machines are expanding their effective workspace at an astonishing rate. Section 2, the biological contraction, human trajectories. But what about us humans? The researchers translate our human attention into the exact same language as AI using a metric they call the effective context span, or ECS. This is basically the token equivalent measure of how much text a reader actually comprehends in a single digital session. And honestly, the data here is pretty grim. Based on decades of observational research, human ECS dropped from roughly 16,000 tokens back in 2004 all the way down to an estimated 1,800 tokens by 2026. And that, brilliantly, but sadly, illustrates the human cost, a stark 87% contraction of our cognitive workspace. 87%. This has been totally driven by our fragmented reading habits and constant digital interruptions, which have ground our continuous screen focus episodes down to an average of just 47 seconds. Think about that. Less than a minute of continuous focus before our brains go seeking out a distraction. So, when we map these two realities together, we get this X-curve. The researchers call this the cognitive divergence. You have the blue line soaring upward, which is AI capacity, and the red line trending downward, which is us. Notice the critical crossover point right around November 2022. That corresponds exactly with the launch of ChatGPT. That was the moment the machine's processing capacity definitively blew past human continuous digital attention. The root of this divergence is deeply fundamental. On one side, we have biology. Human working memory is strictly locked by the badly hitched model to about 7 chunks of information, give or take 2. It's a biological bottleneck that simply hasn't changed over evolutionary time. On the other side, we have engineering. Clever algorithms removed the AI's memory constraints entirely, enabling unbounded scaling. Basically, AI escaped the bottleneck. We didn't. Section 3, the delegation feedback loop. This brings us to the core behavioral fallout of that 2022 crossover, a really fascinating concept the researchers call the delegation feedback loop. Step 1 of this loop is AI capability growth. As these language models get faster, cheaper, and way smarter, using the tool becomes completely frictionless. It's instantly available right on our devices, requiring almost zero effort to engage. And because it is so incredibly frictionless, we slide right into step 2, a lower delegation threshold.
Essentially, the threshold of complexity at which we decide we need help drops significantly. This pushes us to offload incredibly simple routine tasks, just like that two-sentence email decline we talked about at the very beginning. We start delegating things we are completely, 100% capable of doing ourselves. But here is where the hidden cost kicks in, with step 3, reduced cognitive practice. By constantly bypassing simple compositional tasks, we rob our brains of germane cognitive load. In cognitive science, germane load is the mental effort you actually need to build mental schemas and practice your skills. Essentially, we stop practicing how to think through mundane problems.
And that seamlessly closes the loop at step 4, attenuated human capacity. If you don't use it, you lose it, right? Without consistent practice, our cognitive and attentional skills actually start to atrophy. And what happens when your own independent capacity drops? Well, more tasks suddenly feel difficult, which means you lean on the AI even more to do them. It is a perfect self-reinforcing cycle of cognitive de-skilling.
Section 4, Nuance and Reality, the context-wrought phenomenon.
Now, to give you a full picture, we absolutely have to acknowledge that the AI isn't flawlessly perfect. There's a catch to those massive 2 million token memory banks, known as context-wrought. It's basically the lost-in-the-middle phenomenon. Testing shows that when you feed an AI massive amounts of text, its retrieval accuracy can actually degrade by over 30% for information buried right in the middle. Because of how the architecture weighs token positions, the AI naturally favors the very beginning and the very end of an input, while essentially glossing over the center. Sound familiar? But look at how the math actually plays out. You've got the raw gap in 2026 showing AI can hold 1,111 times more context than us. If we mathematically penalize the AI for that context rot, creating a quality-adjusted ratio, the gap is still 83 times larger, 83x. So the processing asymmetry between humans and machines remains absolutely staggering, even when the machine is making mistakes.
Section 5, Reclaiming our cognitive capacity.
So where does this leave us? Well, first, we have to face the hard neurobiological reality. Peer-reviewed studies show exactly how our tech habits physically alter the brain. We're seeing decreased activation in the prefrontal cortex. That's the area responsible for your focus. Our reward circuits are getting totally hijacked by the slot machine effect of our apps. And EEGs, they show persistent suppression of alpha brainwaves, meaning our brains are locked in a state of chronic hyperarousal. Our tech habits are quite literally rewiring our hardware.
But hey, it isn't completely hopeless. The paper lays out several mitigation strategies for us. We need interface designs that use hierarchical summarization to help humans review AI outputs without getting totally overwhelmed. We need epistemic disclosure standards for AI in high-stakes fields. Most importantly, we need educational tools built on cognitive load theory. The goal is to design systems that use AI to scaffold our thinking, rather than substituting it completely. And on an individual level, we desperately need some digital attention hygiene protocols.
As we wrap up, I want to deliver this chilling final thought directly from the paper. The professional typing out that request for a 2-sentence email, they are not going to stop. The AI models are certainly not getting any smaller, so the ultimate question we are all left to reflect on regarding our own daily tech habits is this: what happens to the cognitive capacity that no longer gets used? Think about that the next time you go to delegate a simple task. Thanks for hanging out with me on this explainer, and I'll catch you next time.